Hello everyone, today we'll be making a reflow oven out of a regular toaster oven using the Zallus reflow oven kit. Here are the tools that I would highly recommend having for this conversion process. Of course, have the Zallus reflow oven kit. I would recommend wire strippers, edge cutters, a screwdriver, as well as a screwdriver bit set. And then finally, I would recommend some sort of drill bit set in the event that you need to drill any holes in your oven. The security bit set is handy because many of these ovens have security bits in them, which you'll have to Dremel out or somehow get around if you don't have a bit set such as this. All right, so one of the most common questions I'm asked is what type of oven should I buy? And there are a lot of ovens to choose from. There are infrared ovens, there's forced fan convection ovens, and there are your traditional convection ovens such as this with two elements, and the elements are milky white quartz elements. Now technically they're infrared elements, although the bulk majority of their heat transfer is through the air, or in other words, convection. Now, I would recommend using one of these ovens as is. Now, a lot of hobbyists are adding all sorts of crazy insulation to their oven, modifying the elements of their oven, adding additional elements to their oven, and this is not necessarily needed. I've yet to run into one of these ovens that cannot implement an industry-compliant profile, and at best, all those modifications will simply allow you to shave off maybe a minute or two off of your profile, so they're not really needed. It adds a lot of complexity, so I would recommend simply using an oven such as this as is. Now, one part of the assembly process is planning on how you're going to mount the controller to the oven. And to do that, I give plans for a 3D printed enclosure that you can use to mount your controller, or you can just mount it with the provided standoffs, and you can attempt to mount it in some type of angled configuration on the top, which is probably the most elegant because then you can actually see the PCB as well as the display. Or what's really easy to do is mount it simply to the side. If you plan to mount it to the top, again, plan this out. I would recommend buying an oven that has a top piece that comes off. As you can see, there's screws that bolt this top on, and it's very easy to take it off. So I'd recommend getting an oven like this. All right, so as you can see, without too much effort, we were able to open up the oven and expose all of the internals. But of course, at this point, absolutely make sure your oven is unplugged, or else you could easily shock yourself. So now the next step, of course, is to determine where we should place our solid state relay. And the colors of the wires are kind of relative, so I can't suggest anything based upon the colors of the wires. The best way to determine it is to probe around with your multimeter, as well as simply by inspection deduce how the oven works. And as we can see, there's this orange wire here that connects to the timer of the oven. And of course, when the timer is off, all the elements shut off. So this wire here, if we insert our switch in series with it, in theory, we should be able to control our oven. Now, of course, the oven has this timer as well as this thermostat for a reason. They're mechanical safety features that I wouldn't recommend bypassing. Basically, they're already there. You might as well use them for free. And in that case, should your relay ever fail closed and you're not around, your oven doesn't start up and then consequently burn itself up. So again, these are built in for free. I would recommend using them. And in the next step of this video, I'll show you how to insert your relay in series with this wire of the oven. So there's that orange wire that I was talking about that I plan to insert the relay in series with. Now the first step, of course, is to cut any zip ties that are holding that wire down. And expose the wire such that it's easy to access. Next, we plan a mounting strategy for our relay, and I would recommend mounting it towards the bottom of the oven since heat always rises and we want to keep our solid state relay cool. Now there's this metal plate here that's going to get warm, but it shouldn't get warm enough to the point that it would damage the solid state relay. However, if you plan to run your oven for a long period of time, these solid state relays will eventually heat up on their own, and if you don't heat sink them, you can potentially damage the relay. And if the relay fails, it could fail closed and it could keep on whatever you're trying to control, which could have some bad effects of its own. So long story short, make sure that if you plan to run your oven for, say, 10 minutes at a time, make sure that this chamber in here doesn't get to a temperature over, say, 50 degrees Celsius to the point where you could start damaging this relay. In my case, I'm using this in short reflow profiles, so mounting it in here is an acceptable solution. Whereas if I plan to use my reflow oven all day, every day, I'd probably want to mount this externally to the oven on a heat sink with a fan, such that my solid state relay never overheats. All right, so next we need to cut this wire, and we want to make sure that we have enough slack such that it can go to both ends of the AC portion of our solid state relay. Next step, we strip the wires, and I would recommend stripping about 1/2 inch back on the insulation. So as you can see, I stripped off a little bit more here, and the thing you're also going to want to do is twist these wires such that the wires don't fray when you try to screw them into the relay. Now you can also use ring terminals here at this point to create potentially a better and more secure connection, but I found that as long as you ensure that you screw them in tightly to the relay, they don't ever come loose, and I've had reflow ovens for many years now and have not had any issues. So the next step is to screw these into our relay, and I would recommend bending the wire a little bit like this, such that it hooks around the screw that goes into the relay. So now I have screwed in this wire into the solid state relay, and I'm going to want to tug on it quite hard to make sure that it does not come loose. In addition, when you screw it down, I'd recommend when you do this on your own, try to find an orientation such that your wires are going into the front of the relay. This method right here isn't exactly the most ideal, but there is a little bit of play such that I can insert the wire safely without fear of, say, for example, damaging the wire by screwing this down really tightly. Now, in addition to tugging on your wire to make sure that it does not easily come loose, you're also going to want to make sure that you have a low impedance path from wherever this wire is connected to the oven itself, just to make sure that you're making good contact. If you don't have good contact, you're going to potentially burn up the wiring. So I recommend using a multimeter and ensuring that you have a low impedance connection. You should basically see 0 ohms when you do this. If you don't, make sure your connections are cleaned, and I would recommend starting over. And when I did this, I was at 0.1 ohms, which is about as low as my meter can read. So what I have here is good enough. Next, I'm going to speed up the video a little bit as I do the other side of the relay. So I'm now done with the AC portion of hooking up the solid state relay. The next step is to insert some wiring here for the DC portion to connect our controller to the solid state relay. Here's the wiring that is provided with the kit, and you're going to want to pull the wiring apart about 1 inch or more on both sides. And I believe the wiring is 18 gauge, so make sure you use that on your strippers. So there's one end, and here is another. Now you can see I'm stripping back a lot of insulation. You can always cut off whatever you don't need. Now as you can see, the wires are frayed, so you're going to want to twist them together. Like so. And then the next step, of course, is to tin these wires. Press your soldering iron against the wires for a few seconds, and then gently touch the wire with the solder. And like that, we've tinned one of the wires. Now for the next. And whoops, I've soldered them together. There we are. Now back to our oven. We're going to want to take our wires that we have now tinned and stripped. We're going to again want to bend the wires such that they fit well around the screws. And then we're going to want to screw it in to the DC portion of our relay. Now for the AC portion, the polarity did not matter. However, with our DC portion, of course, the polarity matters. Of course, attach the black wire to the negative end, and of course the positive end to the red wire, such that it makes sense when you're plugging it into the controller. So now that we've screwed in the wires, make sure that you do the pull test as well as the continuity test to ensure that the wires are well connected to your relay. The next step is inserting a thermocouple into the back of your oven. So this is the back of the oven. And what we're going to want to do is we're going to want to drill a hole right up here such that we can feed the thermocouple through that hole. Now keep in mind this is aluminum right here, so you're going to want probably a titanium drill bit, for example, in order to drill through this aluminum, or actually it's probably steel. So I'm going to want to make my hole about 3/4 of the way up. So right about here, I'd say. I'm going to take my nail and I'm going to try to make a little dent in the oven such that I have a guide for my drill bit. And it could be better, but that should hopefully work. So now that I've drilled my hole for the thermocouple, I actually pulled the thermocouple out of it, and I'm planning to drill a hole into the top of my reflow oven such that I can feed the thermocouple in through the top, through the side compartment, and into the hole, such that I don't have any excess of the thermocouple wiring externally to the oven exposed. So I skipped a few steps here. I fed the thermocouple through the top of the oven, and through the side vent I pulled out just enough such that I could feed it through into the back. I then used Scotch tape to adhere it to the side of the oven such that it's not moving around, such that it doesn't get snagged on anything. And I use Scotch tape. Should you have it, I would highly recommend using that orange tape, which is Kapton. Unfortunately, at the moment, I'm all out of Kapton tape, so this will work for now. I also fed through the solid state relay wiring into that hole that I drilled, and then I could also feed through a USB cable should I wish to internalize the USB power. This is just a USB charger that you can get just about anywhere. And the reason why I didn't want to internalize it was because, well, I would have wasted a USB charger, and because they don't really tell you what the temperature rating is on these. And so I didn't want to put it in there in fears that it would overheat and potentially lose its regulation. So for me, it's not that much effort simply to plug it externally. It's not quite as cosmetically appealing to have that extra wire running out, but it's not the end of the world. So now that all the hardware is in place, it is time to mount our reflow oven controller to the oven itself. Now, as I mentioned before, a side mount to the oven is very easy. However, the angle mount is the most ideal. Now, the way I achieve this is I printed a 3D enclosure. Sorry, that's kind of hard to see. And I released the designs for that online should you wish to use your own enclosure. Otherwise, I provide some mounting standoffs which allow you to easily mount it to the side of the oven. Now, the 3D enclosure simply allows you to place the controller like so. You have to screw it down, and then I have some holes on the back. Now, what these are is these are right angle mounting brackets, and I got these at Walmart. You can find these at pretty much any general store or hardware store. And next, what I did is I screwed those into the back of my 3D printed enclosure, and I bent them with a vise such that I can get an angled mounting of the controller like so. And then one thing to note about this enclosure, I don't have a hole in it for the solid state relay wiring, this wiring right here, so I actually drilled that out on my own. And then what you're going to want to do is you're going to want to take this wiring, trim it to size, and feed it into the screw terminal on the board. Of course, note the silk screen, which is the plus, which is the minus. And actually, you're going to want to feed it through that hole before you do that. And then the thermocouple and the USB, thankfully, are easily swappable. So you can screw that down, screw that into the 3D printed enclosure. And then again, this top piece can lift off such that you can bolt this onto the top. And with that, you have an angled mounting solution for your controller. Regrettably, I'm a hardware engineer in the sense of electrical hardware, but I'm definitely lacking on the mechanical side. So later on, hopefully I'll have a better 3D printable solution for an angled mount to the top of the oven. The next step is to verify, the whole point of this controller is that we can actually ensure that the profiles that we're running are acceptable with respect to industry standards. So I'm going to hook this up to the computer and show you how to run the tool to verify that your profiles are indeed compliant.